In this video, we're going to talk about the kidneys and their ability to regulate pH. We're looking specifically at what happens within the nephron itself. So, of course, if you need to catch up on things that the nephron can reabsorb, be sure to look back through the sketch we made in class, looking at specific regions where all of this reabsorption and secretion can take place. So the idea here is this is going to play a pretty big role for us in ensuring that the kidneys can neutralize acids or base within the bloodstream. So even though we're working from the filtrate here, the focus is of course on other body fluids. Now we'll find that the respiratory system as well is very important in regulating pH. But in this case, we actually find that the kidney is a little bit better at neutralizing major swings within body pH than the respiratory system is. So here within this slide, I've summarized three of the major ways that the kidneys are actually able to regulate pH. The idea here that they can produce bicarbonate ion. This includes the reabsorption of bicarbonate ion from the filtrate. They can also secrete hydrogen ions from the blood into the filtrate, and we find that they can actually neutralize some of that hydrogen ion using bicarbonate. So bicarbonate is going to help us to buffer not only the blood, as we'll see when the body has major pH swings, but also here it's going to help us to neutralize the filtrate itself. So this is a pretty complex looking image, but the image is very good at actually dictating the different ways that your kidney tubule cells can facilitate these three processes. So I'm going to go in order here of what's described on the left-hand side. We're going to go ahead and begin by looking up here at the very left-hand side of the image, showing that we originate with free-floating hydrogen ions within the bloodstream. So keep in mind, the goal here is to buffer body fluids like blood and ECF. So in this situation, any bicarbonate that you have, either that which might be produced by the respiratory system, or as you can see here, that which is produced by the renal tubule cells themselves, that can bind to your hydrogen ion, forming your carbonic acid intermediate, which then, as we know, of course, can diffuse or dissociate into water and carbon dioxide. Now, carbon dioxide can be actually secreted here into these tubules for a temporary moment of time, so just absorbed by the tubule cells. And when it comes in contact with carbonic anhydrase, the enzyme that we learned was made by erythrocytes as well, then that carbonic anhydrase can catalyze the reaction by which CO2 binds to water, thus forming this carbonic acid intermediate once again. Now within the tubule cells, carbonic acid again can dissociate into bicarbonate ion and hydrogen ions. If you follow that, bicarbonate ion can make it back into the blood to buffer that body fluid. But these hydrogen ions that you see end up being pumped, as you can see, right over here into the filtrate. Now it's important to note right over here that this is made possible by the reabsorption of sodium from the filtrate. And this reabsorption of sodium is going to be facilitated by a sodium-potassium pump, ensuring that the concentration of sodium within the tubule cell is such that it actually can continue to be reabsorbed here from the filtrate. So as long as that is possible, you can continue to push these hydrogen ions out of the tubule cell and into the filtrate. Now, once the hydrogen ions are within the filtrate, that of course is going to begin to alter pH. By nature, urine is more acidic than other body fluids, but it still needs to be maintained at a safe level. What we find here is that the tubular pH itself can only become so low as 4.5 before, at which time it actually begins to limit the number of hydrogen ions can be secreted into the tubule and into the filtrate itself. So it's important to not only be buffering the blood, but also you want to make sure you are now buffering your glomerular filtrate. Thus, enter bicarbonate ion once again. Now in this scenario, bicarbonate ion is actually going to be in a compounded state in the form of either sodium bicarbonate, or as you can see in this very next slide, disodium phosphate. Right? This phosphate group here would serve the same role as bicarbonate ion. And what happens is that both of these dissociated ions, either the bicarbonate ion or the phosphate, can actually serve as a proton acceptor. So they can both pick up the hydrogen ion. Here the bicarbonate would form your carbonic acid intermediate, by which it's neutralizing your free-floating hydrogen ion. And in this scenario, your disodium phosphate can actually dissociate, removing one positively charged sodium ion and thus gaining one positively charged hydrogen ion, forming monosodium phosphate. phosphate. Once again, in this example, you've seen that it actually neutralizes the free-floating hydrogen ion. So in that situation, you find that you can actually maintain an appropriate pH of the filtrate within the tubule itself. One other step that you'll notice right over here that's unique to bicarbonate ions specifically is that not only will you have carbonic anhydrase within the tubule cells themselves, but you'll also have this carbonic acid carbonic anhydrase enzyme actually produced here within what we would think of as your microvilli of the tubule cells. So it's referred to as a brush border enzyme in that situation. This particular enzyme within this location can then take your carbonic acid intermediate and then convert it into water and carbon dioxide. So once again, we see the carbon dioxide that's produced can be reabsorbed by tubule cells and can be used to once again help you to actually eliminate hydrogen ions and secrete them, or form more bicarbonate to then be returned to the blood and buffer the blood. And so that more or less summarizes the three major ways that the kidneys can function to regulate pH. We see again, you're regulating not only the pH of blood, which is really the most crucial in this situation, but also regulating the pH of your filtrate.